In this activity, we're going to take a look at an introduction to similar triangles. We're going to start by first taking a look at congruent triangles. Two triangles are said to be congruent if their corresponding sides are all equal length. And in congruent triangles, all corresponding angles are also equal. The symbol we use to denote two triangles being congruent looks like this. Now, let's take a look at similar triangles. Two triangles are said to be similar if all corresponding angles are equal, and the corresponding sides in each of the triangles are proportional to each other. The symbol we use to denote two triangles being similar looks like this. If two triangles are similar, their side lengths will be proportionate. That is, each side length of the smaller triangle is scaled by the same value to make the larger triangle. Let's consider the two triangles below. Are these two triangles similar? Well, the side length for side AB is 3, and the side length for side DE is 6. The side length for BC is 4, and the corresponding side EF is 8 centimeters. Finally, side CA is 5 centimeters, and its corresponding side DF is 10. We can see that the sides in the smaller triangle, triangle ABC, are half as long as the sides in the larger triangle, DEF. We can say that these two triangles are similar because corresponding sides are all scaled by the same value. When two triangles are similar, we can also say that corresponding angles are equal, which means that angle A is going to be equal to angle D, angle B will be equal to angle E, and angle C will be equal to angle F. If we're told that all three angles are equal, we do not need to prove the triangles are similar using the scale factors. The equal angles alone prove similarity. For this question, we're asked if the two triangles are similar. For these two triangles to be similar, corresponding angles must be equal. Let's start with the two angles that we know. We can see that angle N and angle R are both 40 degrees. But we don't know the values of the other corresponding angles. We're first going to have to determine what angle M is and what angle Q is. We know that all of the angles inside of a triangle must add up to 180 degrees. So, in triangle LMN, the angles must add up to 180. We're already told that angle L equals 33 degrees, and we're told that angle N equals 40 degrees. If we subtract the sum of those two angles from 180 degrees, we'll be able to determine the measure of angle M. 180 minus the sum of 33 and 40 equals 107 degrees. Let's write that in here. Now, in triangle QPR, we're told that angle P is 107 degrees, and we're also told that angle R is 40 degrees. Again, if we sum these two given angles together and subtract that from 180 degrees, we're going to be able to determine the measure of angle Q. 107 plus 40 is 147, subtracted from 180 gives an angle of 33 degrees for angle Q. So angle Q is 33 degrees. Now we can see that the corresponding angle to angle L is angle Q, and they both measure 33 degrees. The corresponding angle to angle M is angle P, and again, they also measure the same 107 degrees. We can see that the corresponding angles in triangle LMN are the same as the corresponding angles in triangle QPR. That means that these two triangles are similar. So therefore, triangle LMN is similar to triangle QPR. The order in which we write down the letters for each of the triangles is important. The corresponding angles must line up. We have angle L and angle Q are corresponding, and they're both the first letters in the triangle notation. The middle letter, M, is corresponding to the angle P, and N is corresponding to R. Once we know that two triangles are similar, we can then build proportional statements to include a scale factor for the two triangles. If we know that triangle ABC is similar to triangle DEF, we know that angle A is equal to angle D. We also know that angle B is going to be equal to angle E. And finally, we know that angle C is going to be equal to angle F. The proportional statement for these triangles is side AB over side DE is going to be equal to side BC over side EF, and that's also going to be equal to side CA over side FD. And these ratios will also represent the scale factor of these two similar triangles. Given the two triangles below, determine the missing dimensions. Before we can state that these two triangles are similar, we need to show that each of the corresponding angles are equal. And before we can do that, we need to determine what each of the angles are in each of the triangles. In triangle ABC, we can see that angle C is missing. Again, we know that if we subtract the two given angles away from 180, we'll be able to determine the missing angle. We have 87 plus 20, which is 107, and when we subtract that away from 180, we're left with 73 degrees. So we know that angle C is 73 degrees. In triangle XYZ, we can see that angle Y is 73 degrees and angle X is 20 degrees. When we add those two together, we get 93, and subtract that from 180, we're going to determine that angle Z is going to equal 87 degrees. So angle Z is 87 degrees. We can now see that angle A is equal to angle Z. We can also see that angle B, 20 degrees, is equal to angle X. And finally, we can see that angle C, 73 degrees, is the same as angle Y. Because the corresponding angles are equal, we can now state that triangle ABC is similar to triangle ZXY. And because these two triangles are similar, we can write our proportional statements stating that side AB over side ZX is going to be equal to side BC over side XY, which is also going to be equal to side CA over side YZ. Now that we have our proportional statements, we can determine the value of X. We can see that X represents side AC. So we're going to be using AC over YZ. And we also have to determine a set of corresponding sides where we're given the side lengths for both sides. And that's going to be side AB and side ZX. Substituting in what we're given, we know that side AB equals 9, and we also know that side ZX equals 6. We're trying to determine side CA, or side AC, which is represented by X, and we're told that the corresponding side, side YZ, is equal to 2.1. Now, with a little cross multiplying, we get 2.1 times 9 divided by 6 is going to equal X. Getting our calculators out, we can determine that the value of X is going to be 6.3 centimeters. For this question, we're asked to write a proportional statement and solve for side A and Q. We're told that triangle ABC is similar to triangle PQR. So our proportional statement, make sure that we follow the order. We're going to say that side AB over side PQ is going to be equal to side BC over side QR is also going to be equal to side CA or AC over side RP or PR. So let's put in what we know. We know that side A is 18 meters and side PQ is 10.8. This is the relationship that we're going to use to solve both side A and side Q, since we know the length of both side AB and side PQ. For BC, we're told that that's A, and QR is equal to 11.4. So we're going to use this relationship right here, cross-multiplying, to solve for A. Let's go ahead and do that before we continue on with side CA and RP. So cross-multiplying, we're going to get 18 times 11.4 divided by 10.8. And that's going to equal the length of side A. Pulling out your calculators, we have 18 times 11.4 divided by 10.8. That equals 19. So that means that side A is going to be 19 meters long. Now let's take a look at what we know about side CA. We can see that CA is 7 meters and RP is one of the values we're looking for, Q. So we're going to use the relationship where we know both the corresponding sides along with the relationship where our unknown is. So let's write that. We get 18 over 10.8 is going to equal 7 over Q. So let's do some cross multiplying. We're going to multiply 18 times Q, and then we're going to multiply 7 times 10.8. We end up getting 18 times Q is 18Q, and then 10.8 times 7. The last thing we have to do is divide both sides by 18 to isolate our unknown. Getting our calculators out, we're going to multiply 10.8 times 7, and then we're going to divide by 18. And we get 4.2. That means that Q is 4.2 meters long. For this next question, we're told that triangle JKL is similar to triangle TUV. So let's start off by writing our proportional statements. We know that JK over TU is going to equal KL over UV, and that's also going to equal LJ over VT. Now, our unknowns are on KL and UV, so we're going to have to include this proportion in our solution. We also know the value of JK, that's 7 centimeters, and TU, which is 10 centimeters. So we're going to use this relationship right here to solve for X. We don't know anything about the length of LJ or VT, so we're not going to be using this at all. Let's substitute in what we're given. So JK is 7 centimeters. TU is 10 centimeters. KL is represented by X, and UV is represented by X plus 6. So now all we need to do is cross multiply and isolate X. So when we cross multiply, we're going to get 7 times X plus 6, and that's going to equal 10 times X. Using our distributive property to bring the 7 into the brackets, we get 7X plus 42 is going to equal 10X. Moving the 7X over to the right-hand side by subtracting 7X from both sides, we get 42 is going to equal 10X minus 7X. Let's write that down. 42 is going to equal 3X. And now all we have to do is divide both sides by 3 to isolate X. And what we end up getting is X equals 42 divided by 3 is 14 centimeters. And that's how we can use similar triangles and proportional statements to solve for unknown side lengths or unknown values in triangles.